Contactors are on and off switches used mainly to turn motors or compressors on and off. They come in a variety of sizes and configurations for all voltages and amp draws. The single pole contactor is the most common contactor seen in a lot of residential air conditioners. Often the single pole that remains closed all the time is used to energize crankcase heat to the compressor in the off cycle. The contacts of the contactor are drawn in whenever 24 volts is applied to the coil that sits in the bottom of the contactor. An electromagnetic field is set up when voltage is applied, and this draws the contacts down, allowing the line voltage to flow through the contactor to the load. Over time and use, the contacts will become pitted and will provide an uneven contact which can affect the operation of the load. Contactors should be checked during periodic maintenance to make sure the contacts are still in good shape. You also want to make sure that you do not exceed the voltage and amp draw rating listed on the contactor. Excessive voltage and amp draw can lead to early failure of the contactor. The most common technical support call we get is, "I can push in the contactor and the compressor and fan runs fine. But when I call for the thermostat, nothing happens. What's the problem?" You will notice in most wiring diagrams that the contactor is supplied voltage through a circuit that includes a low pressure switch, a high pressure switch, and possibly other safeties. These safeties need to be checked to make sure that power is flowing through these switches, energizing the contact. If you've had a high pressure situation or a low pressure situation, that may be the problem why you can push the contactor in and everything runs fine. But when you try to energize it from the thermostat, the power is not going through that high pressure switch or low pressure switch because it's still open. Another device that is used by many manufacturers is a CLO, or a compressor or current lockout device. This device is in conjunction with the safety switches so that if a limit switch or a pressure switch opens, it will de-energize the coil to the contactor. The lockout relay will then lock out the system until the situation or the power is killed and restored and the pressure or the limit switch situation has been resolved. A common method of troubleshooting this type of situation is called the Hopscotch troubleshooting circuit method, where you put one probe of your voltmeter on one side of the load and then take your meter, the other probe, to the other points throughout the system to find out which switch is open, causing the motor not to run. As you check through the safety circuit and checking the safety switches to make sure that they are closed, you don't want to forget where they plug into the control board. Many times technicians check out the switches and they're closed and they say, well, there must not be a problem there. But then they go and check the plug where the safety switches plug into the circuit board and find that a pin is loose or is not making contact where the plug goes into the board. So don't forget to check the plugs on these systems either.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.